Okay, number 6. It's a build off of number 5, and this is part of the centripetal force ones. The car has a mass of 1,200 kilograms. What is the centripetal force, or what centripetal force is required to produce the centripetal acceleration above? Draw a quantitative force diagram. So first, let's look at the two equations that we have for centripetal force. Force centripetal equals velocity squared times mass divided by radius, and also net, because centripetal force is net force. Mass times net force is equal to mass times acceleration. Which, if you followed the last couple of videos, we derived an equation from that, which gives us acceleration that we used in step 5 to give us an acceleration of 10.581 meters per second squared. So it's wanting to know what the net force would be, or the centripetal force. Because net force and centripetal force are the exact same thing, we have the two different variables to solve for net force. We have mass, which is 1,200 kilograms, and we have 10.581 meters per second, which is our acceleration. So we can just, times them to get the net force, or the centripetal force. So 10.581 times 1,200 kilograms will give us a centripetal force of 1,26972. But that's not it. We have to draw a force diagram, which will show us a little bit more onto that. So because the weight of the car is 1,200 kilograms, we have to convert that into newtons, which is actually negative because it's going down. 12,000, because you have to add the extra 1 in there, because it's every 1 kilogram is equal to 10 newtons. So that's what that's going to look like. But we have a net force, so they're not going to be equal. There's no going to be equality. There's actually going to be it's going to be force normal plus force gravity will equal our 1,002 or 12,697.2. So we'll set up an equation that says force normal plus force gravity is equal to that. But we know force gravity, which is equal to negative 12,000. So when you solve that, you'll add 12,000 onto each side to solve for force normal, and you'll get a force normal of 24,697.2. So if you want me to do that in calculator, I guess I can do it. So 1, 2, 6, 9, 7.2 plus 112,000, 1, 2, 3 is equal to, I don't know if you can see that, 24,697.2 newtons. There you go.